Hi, my name is Vladimir. Came here from Moldova. Thank you for coming too, and thanks to the organizers. So every year I send 2 talk proposals, like Plan A and Plan B. And this year Plan A was merged into the panel yesterday, so this presentation is sort of my Plan B. I guess I didn't bring anything to show and tell this year, so this talk is about just the loose collection of interesting language features that you may or may not have heard about. So Andre likes to make presentations titled 3 Cool Things About D. I'm going to show you like 50. Time allows. And to make things even more interesting, could someone please give a microphone to Mr. Walter Bright? Mr. Bright, I'm gonna just ask you about your opinion on the different things that's gonna be here, and I want your opinion if it's like a bug or feature. Thumbs up or thumbs down. So, there we go. The slides are available temporarily at this very, very short URL if you want to follow along, though I did try to make the font size as big as possible.
Bug.
If you are watching a rerun, was there something?
I just said bug.
Thank you. If you are watching a rerun, then I will have made the slides available as a permanent link on the DConf website. Let's begin. Oh, the part above should have been blurred. I was going to ask you what is the name of this language feature. So who knew what was the name of this language feature? Hands up. 1, 2, 3, 4, 5, 6. Okay, all of you with the hands down, you would not have been allowed to post in one day in December 2014. I have, around the time on the forum, we had an influx of spam coming through the web interface, and I thought, well, why not add a CAPTCHA that allowed to distinguish between D programmers and non-programmers? And this was one of the questions, like identify the name of the feature that's here. And in retrospect, and as it has been pointed out to me, it was a terrible decision. So it was rolled out in the same day. But most of you here would not be deserving to be posted on the forum on that day. So next question. What is this useful for? I understood that sometimes it is useful for interface code. So what's happening here is you say new class widget, and widget is not the name of the type that you create. It's actually the name of the parent class. And inside you can override the methods that you want to override, or even add fields, or really put anything that you would otherwise put in a class definition. And you will construct a new anonymous class instance with that type. The type is anonymous. Next question. Too bad the blur is not working, but what's going on here? Who knows?
Feature.
Yes, well, what does this function return? Int. Where does it say that? Right, so auto is just a placeholder for when you want to add something but you don't want to write a type, and you have to write something there, but if you don't write something there, that's not a variable declaration, that's just an assignment, that's an example. So you have to put auto there. As you probably know, every type in D has an initial value. So ints have an initial value of 0. And you may think that's convenient, but this was chosen because it was the value that was closer to invalid. Generally, the logic is to have initial values to have an invalid value so that you catch bugs quickly. So for example, for ints we have 0, but for floats we have nan, and for chars we have that thing. And any comments regarding this slide? Have you all been asleep at Don's talk? Come on.
Yeah, Don thinks nans are a bug. I think they're a feature. I think they're a feature. So.
No one? What was that? Yeah, that's false. Let me fix it for you. 10 points for Gryffindor.
Sorry? For the slide before, the initial values, those are acceptable, but for dchar, I think it's a strange value because it is not the last valid Unicode character. So the init value for dchar is 0xFFFF.
Is that the replacement, the Unicode character that's, what was it called?
Yeah, at the end of every plane there are some invalid characters. This is correct, but it is not the last. So I don't think.
Well, the reason why this symbol was chosen, as I understand, for char, is that it is not valid in an UTF-8 byte stream.
That's right.
Thanks. You can also use .init with structs. So if you declare a struct and you give the initial the field's initial values, they will be like that when you declare a new instance of the struct. But you can also use expressions there. So you can this will invoke the compile time function execution. And what's interesting is that you can also use an anonymous function to compute things that were not computable in an expression. So although you might be able to compute this particular example, factorial of 10 using ranges or something from SCD algorithm, this is another way to initialize, for example, lookup table if you need to.
Vladimir, can I raise, you mentioned that, okay, we can initialize a struct with some const and have initial field, but we have prominent, it's not a bug, but it's current implementation in STD data time, that time zone is current time zone for this machine, and because this class is null, and you can use init of data time to your purposes. Possibly the best choice was initial time zone was UTC. Then you can have data time init as usual, as normal type, but for data time init is unusable. Init is very difficult when you have instituted classes.
Yes, I run into the same datetime problem myself. Jonathan, any comments? Let's please give them a mic.
Well, the init value is kind of supposed to be invalid, but the reason that it's null is because when systime was written, it was impossible for it to be anything else. The language, you couldn't initialize a class at compile time at all. And last time I went to try and fix it, there was a compiler bug that prevented me from assigning anything to it other than null. I believe that compiler bug was accidentally fixed with by someone fixing something else recently. So that will be fixed soon. It will probably end up with a time zone that's specific to it, so the init value is still distinct. But it will be fixed soon so that doesn't like segfault like it does right now. But the reason it does has to do with implementation limitations in the language that have finally been fixed.
Thanks. Awesome. Next slide. So, void initialization. You probably know about this, right? Who doesn't know? Who does not know about void initialization? Raise your hands up. Show yourselves. Get out. I'm just kidding. Void initialization is, just to reiterate also for the people watching online, a way to declare that a variable should not be initialized. Indeed, all variables are initialized by default. That is awesome. It kills a whole class of bugs outright. And you might think this is a performance issue, but it's not really because it can be optimized out using data assignment elimination. Is it right, Mr. Bright?
That's right. Data assignment elimination will usually eliminate the default initialization if you follow it up with your own initialization, so it rarely costs anything. Also, one advantage to having the initializations be 0 is if it's static data, it winds up in the BSS segment, which is set to 0 by the operating system, so it's very convenient.
still, if you do have larger structs and they have a longer living and they may be initialized with further functions that the optimizer doesn't see, you don't want to put, while you put them on the struct, spend all the time initializing them and only to be overridden like a few maybe nested function calls later.
Right.
So it is important to know about it and probably use it in many cases.
Equals void is a optimization.
Yep. So this is, you all know about this. This is not a secret. It's just introduction to the next slides. So in the same way how you have void pointers, you can also have void arrays, which are essentially slices of untyped memory. It's just essentially a void pointer and a size d. And when I introduce d to my friends, they say, okay, what is the length of a void array? What does it count? And the answer is actually really simple. It counts whatever size t counts, bytes. And even though you can have static void arrays, because, you know, if you can type a dynamic array of int, you can have a dynamic array of void. If you have a static array of int, you can have a static array of void. However, if you actually try to use them, you get an error. There's something missing in this slide. Who knows? Nobody knows. Awesome. This is a secret you've learned today. The reason... Oh, someone knows. OK.
So what's the exact question again?
Why this won't compile?
Why? Okay, well, I know it does not compile. I've come across it, but I mean, an array of void 5 is not. I mean, that would mean an array of 5 void elements, of five values of type void, and there is no value of type void.
Why?
Why there is no value of type void? Well, void. That's what DMD says. Voids have no value.
Right.
I mean,
Did you just try this right now?
No. I've come across that in templated code.
Okay, right. So remember when I said that every type in D has a .init? I lied. Void does not have an init type, which is why you cannot type, you cannot write this, because it gives you an error, because it has no initial value. So you have to do something like this, as weird as it is. Void 5r equals void.
Feature.
Sorry? The size of the void array, well, as I mentioned earlier, 5, it measures whatever size t mentions. And size t in, I think in all implementations of C, it measures bytes.
Yeah, unlike C and C++, where if you try to increment a void pointer, it gives you a compile error. In D, a void has 1 byte in size. So it's very convenient to be able to do arithmetic on void pointers, even if you never look at the data, which is why it works this way. So more specifically, a void 5 is 5 bytes long.
Thank you.
Just a note on that. This is also an extension of GCC to just arbitrarily set the size of void to 1, so that you can do pointer arithmetic with void pointers. But still with this, if you say you declare a static array of type void, you may get away with initializing it like this. But you cannot index it, you cannot iterate over it, and things like that. So your void initializer fixes this, but try doing it for each over it.
Thank you. Was it a question?
I think it was a statement.
Okay.
But also find it interesting that, you know, yet another D feature finds its way into C and C++ with the extension you mentioned.
Next secret.
Walter, is any specification if you try to cast usual array to void array? For example, C and C++ standards says you in any time can cast usual pointer to void and back, and you have no problem, no undefined behavior. What is behavior of casting usual array to void array? If you casting, for example, int array to void array in function, what do you have? It's a defined behavior, it's any specification in the language, what should happen in this case or not?
I don't understand. You can cast int array to a void array, right?
Yes, yes. Is any
and you're saying
specification
what's that
what
for?
should happen in this case? And any guarantees that, for example, C++ has guarantees that if you cast any pointer to void and backward, you have no any corruption of your data. It's defined behavior in C++, for example. Have we any guarantees that you can cast your int array or double array to void and backward, and you have no corruption in the data?
Yes, you can do that.
Okay.
One interesting thing about void arrays, by the way, is that they are, as far as the garbage collector is concerned, they are marked as having pointers. So if you allocate a void array and copy some D classes or things with pointers in them, you will not get memory corruption. And we actually had an issue with this because in D1, the std.file.read function, it returned a void array, and that allocated it in the garbage collector heap, and it was marked as having pointers. And if you read a JPEG, that would cause a problem because you would have a lot of files pointers. It was fixed a long time ago, but still a curiosity. All done? Next secret. Next secret. There. So you probably know about file and line special keywords. They're the same as in C. D also adds a few new ones. Module and function and pretty function, which are pretty useful for debugging. However, in C, these are preprocessor macros. In D, they are treated a bit differently. So if you, for example, place them in as the default parameter of a function, they will be evaluated as not where they appear, so not on lines 3 and 5, but on wherever the function is called, lines 9 and 10. And this is pretty awesome for logging because you don't need to use something like string mixins to be able to get the line number or look at the stack trace. So lines 9 and 10 are right where the functions are called.
This is one example of a clean language design wouldn't do this. This is a kind of a dirty thing to do in the language, but it's so darn useful. So it's a feature.
Thanks. And for the next slide, I'm going to ask you to only look at the last line, because it was supposed to have some blurring, but this web browser doesn't support blurring. And what's happening here? Don't look at the first two lines. Yes, this is a struct initializer. But I'm going to change one symbol. And what is it now? Who knows what's going on here? Lambda. What's with the syntax? What's with this x colon y semicolon? Correct. So one symbol, this is an example of of the DMD parsers. I understand that it has to have infinite look ahead. It doesn't know what it is until it's read the whole thing and reached this semicolon or not.
Well, I guess that's a feature.
So I want to talk about templates for a little bit. Templates in D are essentially declare their own namespace. So you can instantiate a template and then refer to the fields inside it. D also has eponymous templates, I think that's how it's pronounced, where you declare a template and inside it you declare the field with the same templates. I believe it's the same as in C++. So you can refer to just the template instantiation without having to type sqr bank3.sqr. What's interesting is that you can declare fields inside an eponymous template that are not otherwise reachable from outside the template. Well, it's not an access protection issue, this is a name lookup issue. And I don't know, maybe there's some trait to crack it open, but as far as I know, these are not reachable from outside the template instantiation.
I didn't know about that, and I'd say it looks like a bug to me.
So implicit function template instantiation is when you just declare template function and you pass it some parameters and it instantiates with the correct type. So if you call this function which takes any argument and this function just prints during compilation the type, for 5 you'll get int, for 4.2 you get double, and for the hello literal you'll get string. By the way, the interesting thing about this slide is that string is actually a library type. It's declared in object.d as an alias of an array of immutable chars. And the compiler here does something clever, and instead of printing immutable char array, which is really confusing because who calls strings that in real life, it converts that to string. Even though theoretically, if someone would write an replacement for object D, the compiler would then be wrong. Let's see what this slide is about. Okay. This is just continuing with the implicit function template instantiation with the eponymous templates. So, this function is just written as this function, as this declaration. This is just a long form of this one. So, when you put two pairs of parents, it just moves one above in the template instantiation and another in the below one. And let's say you have a function that looks like this. This is, you probably know as d.conf.to, which takes a explicit parameter to the type to which to convert, and it returns the type, and it takes an implicit parameter of the type from which to convert. And there is actually a problem with this function definition, which you may or may not encounter depending how you use this function. If you just call it with converting b, when b is a type and some value of type a, this works. However, let's say you need to make a specialized template which says, I want a function that converts to b and I don't want to pass any template parameters. And this doesn't work. Why? Because we instantiate the convert template with just one parameter, and the second parameter is not specified. So we get an error. Who knows the solution to this? Awesome. The solution to this is to split the argument lists and rewriting this as more explicit form. So we want to write convert with just the explicit parameter as a template, and inside it we want to write an implicitly instantiated function, which will then accept the implicit value, and then we can create an alias to this template with just a type.
Feature.
Thanks. Alias template parameters. They are awesome. They can take anything that an alias can, but also something else. Who knows? Something you can define as you can pass to an alias template, but cannot declare in an alias declaration. Or alias something equals. Correct. Literals. Awesome. And another interesting thing about alias parameters is that they do context binding sometimes. So if you have a global template print which takes an alias and we just print whatever is given, and we have a struct, and we say we want to instantiate the print template with a field, and that works. And if you call s.printf, it will print whatever is in the f field. If you do it with a function, it doesn't work. What's interesting is that the way this works underneath. Print is written to be a sort of method of s, because this makes print to have a this pointer. It points to inside the structure. And this allows actually a lot of very interesting constructs which I will not present today. Mr. Bright?
That's a very deliberate feature.
Yes, it is.
Can I make one addition? There is one sort of consequence to that often catches people by surprise. If, for example, you have like a delegate, and then you try to add also an alias template parameter to the same method, which already has a context, it will fail because it will need to have two context pointers, and that's not possible.
Right.
And like it often.
I heard SDC supports that though. Thank you. Multiple contexts. Yeah, that would be awesome if we had that, but I understand it's not an easy effort. Great, great, let's get it done. So I wrote a blog post about this a while ago, so I'm just going to reiterate a few points here. We have so you can declare an identity template that just takes an alias parameter and aliases this to itself. It's actually available in STD traits, though it's not documented. This is just the short form, which might be confusing. This is the long form. Template identity, which takes an alias parameter and aliases itself to the parameter. You would think that this is a completely useless template. Why would you ever want a template that aliases to itself? It does absolutely nothing. Well, it turns out it has a few uses. So one of these is to work around a syntactic corner case, which is when, for example, you want to take the parent of a symbol and alias it to something. And currently, the grammar does not allow you to do that. And I understand that this is currently just a bug and it will get fixed. Yes, it is.
Is there a Bugzilla entry for it?
Good question.
If there isn't, it won't get fixed.
Yes, you're right. And so this will just not work. You'll also print that error and 3 more. But what you could do is something like this. So I'm going to alias identity to I for short. And if you just wrap the traits expression into an instantiation of the template, it's going to work. Because apparently you can't write traits right after an equal sign and alias declaration, but you can write it in as a template parameter. So all this does is takes the traits expression as a parameter and passes it out back to the alias declaration. So this will probably not be necessary in a year or so I hope. But also you can use it in combination with the uniform function call syntax. So let's say you have an array and you define a local which does something to the array, and just as an instantiation of the map template. And you want to use UFCS with the thing that you created. And it won't work if it's all inside a function, because name lookup for UFCS is only for the global scope. This will just tell you that there's no such property on R, and it will look in the global namespace of all the modules you've imported that it doesn't work. So I understand this is a feature, but even though I don't know why this is so, there's probably a very interesting reason.
I can't think of it at the moment. That doesn't. These kind of things you kind of have to look at for a while.
And what you can do to work around it is to prepend iBang in front, and now it works. It looks like some really weird syntax, but to each their own. Sometimes it's useful when you have a long chain and of UFCS function, like do something, .get, and you just like that, match the regex. By the way, I heard we're removing curl, so this probably won't work soon, .get. And you take the front and, oops, you want to prepend something to that string. How do you prepend it in UFCS chain? Any answers? Maybe I don't know, and I'm just reinventing the wheel here. So yeah, you could do 2 assignments and assign that to the thing, and just do the prepending like it does at the top there, and go on. It's just ugly that way. Well, I'm not sure if this is ugly or not, but you can do this. This does look a little confusing. What this does is pass a function literal as the alias parameter of the identity template. And actually, that gets evaluated on the spot. So you say S is the result of the previous expression, front in brackets, and you just prepend the whatever string you want, and then you continue your UFCS chain.
Sorry, could we go back to the previous slide just for a second? So does it work to do alias increment all equals identity of the map, and then just array.increment all?
Oops.
And if not, why?
Could you repeat that, please?
Yes. Yeah, so in this example, if instead of doing array.I increment all,
yes,
we did alias increment all equals I of map, and then array.increment all, would
equals
that work?
I.map.
And if not, why?
Equals r.map. Yeah, of course you can do r.map, bang, whatever. Because map is a global function.
I think like I can actually answer Joseph's question.
Okay.
It will. The question was if your alias identity template itself locally will work, and the answer is, as far as I understand, of course no, because right now it works only because identity template is a global symbol.
Exactly.
So it participates in UFS lookup, and as soon as you make it a local symbol, it will stop working.
Yes. We use it as a step ladder, but we need to place the step ladder on the ground first. We can't place it on an imaginary step ladder. Yes. Template this parameter. So sometimes you need to call an object and get the type of this object, of the object you're actually calling on, which is different from the type of the this pointer, because the type of the this pointer is dictated by the annotations on the method, if you've been listening to Steven's talk. So if you, for example, want to get the real type, we declare an S, but if you want to get the real type of the variable that we're calling the thing on, you can't use type of this. If you don't, so this function has const there. If you don't put const, then it's just that your method will not be callable with constant objects, because it will be considered a mutable method only for mutable objects. So there is a way around it, and it is to use this interesting syntax, is to type this and an identifier in the template parameters. So this will actually get you the type of the variable you're using. This is useful because what this also does is it makes the function specialized by the type of this pointer, of the object you're calling it on. So there will be 3 instantiations in this case. Each one will print the type of the variable that we're calling. So for the first one, it's going to be mutable, so it's going to be just S and const and immutable S. Yes?
Should that, oh,
Yes. I don't have a lot of slides, so please fill the time up. I'm halfway done. Okay. Next slide. Next secret. Who knows how many ways there are to write this? Functional literals. How many? Give me a number. Shout it out. Just shout it.
5.
5? More than 5? A lot more than 5. Not exactly. I counted 10. So these are all essentially mean the same thing. You can omit certain parts of the syntax. And you can probably see a pattern here. So you can omit the parents in either case except the last one, because there will be nothing left. There's more. You mean this syntax? Can someone tell me what's wrong with this syntax? It was on the forum very recently. Yes. This is actually a combination of number 6 and number 10. So you can see what's going on here. This is number 10 up to here. And this is number 6. And this will return a delegate which returns the string wrong. Don't do this. It will not do what you want. Oh, yeah. It should probably be just a compiler warning or error. Statements as expressions. You can do this. Why would you do it is not my business. But you can, if you want to call a function and want to execute want to do some code that can't fit in an expression, you can wrap it in a functional literal and then call it immediately. Yes?
For example, if you want to wrap some specific statement with the safe or trusted or pure, that's the easiest way to do so.
Oh, awesome.
So wrap it into delegate and immediately execute.
Yes. So to repeat what was said, this very useful use case for this is to wrap in a safe or trusted delegate and then call it immediately when you just want to escape from safe or trusted. Or just wrap it in safe or trusted. Is that right?
So basically, if you want to just repeat that 1 or 2 statements in a function under control of pure or safe.
Ah, awesome. Yeah, this is a way to write pure expressions, not statements, not functions, but pure expressions. Awesome. This is a very good use case. So D allows doing this. You can declare variables inside an if loop. This is pretty awesome.
So
Yes, question?
This expression, if the argument of fun is lazy, then it's useful too. I actually use that a lot.
Yeah, it's on my next few slides.
Okay.
I'm going to talk about lazy parameters too. You can do this, and of course you can do this, though again I have in this particular case I'm not sure why would you want to do that.
There's another reason to do that.
Yes.
And that is because it's an expression goes there, and sometimes, expressions can't have loops in them.
Yes, that is exactly the reason why
So
would you want.
that's one
But the
way
question
you
is,
could-
why would you want to do it inside an expression and not just pull it out of, put it in the function that's calling the thing? So yeah, you could do that if you want to have it. Yes.
Because of lazy.
Because of lazy. Oh, interesting. Good idea. Lazy. This was supposed to be blurred, the lazy thing. I was going to ask you, when is this function valid? Just which functions can take a void parameter? And yes?
No. I was just shouting this. It's awesome.
Yes, it is. Lazy parameters are the only case where a function can take a void parameter, at least as far as I know. And this is awesome because you can do very interesting stuff. So I should not need to introduce lazy parameters, just in a few words, they are evaluated only if they are used. So under the hood, looks something like this. The function, the lazy parameter is actually passed as a delegate, and the argument is a delegate literal, which returns the value. Next secret. Type info. So some languages have first class types. This is, yes, a question.
Yes, you just said the lazy parameter is converted internally to a delegate. Does that mean if I use it in the function twice, it will get evaluated twice?
Yes, it actually will be called twice, which is sometimes useful. I recall that I think SED parallelism uses this for evaluating something, and you just pass it as an expression. It evaluates it multiple times, but in different threads. I might be wrong.
So random will then actually get two random different numbers in the same function?
Yes.
Okay, thanks.
Which may not be what you want. I actually forgot to mention that. Thank you. So some languages have first-class types. This is an approximation of that in D. Every type in D, the compiler generates a type info object, which is a class. And it has a number of very interesting properties. So you can query the name of the type at runtime. And although you could use just string of or something, the interesting thing is that the type info is a class. It's an abstract class, and you could pass it around. A descendant of the class is class info, which allows you to construct the object. So the only language that I'm personally familiar with that has first-class types is Delphi. In Delphi, you can say class of object or whatever, and you can then instantiate it. And this allows you to, instead of using object factories, you can use type class info, which allows you which saves you the effort of writing a class or a function which which works as a factory for the class you need. An interesting thing very related to type info is RT info. And this one is very interesting. For every type in your program, the compiler will instantiate a template. And you can put anything you want in the template, though you have to change the runtime for it. And you can put anything you want in the template, and it will be made available as part of the type info. So for example, one can think any number of uses for it. Right now, it's not being used in the official runtime, but I understand it's being used for a precise garbage collector. Awesome. Next secret. This is my most reviled secret, object.factory. What it allows is that you have the fully qualified name of a class, any class in the program. You can construct it. And you might think this is very interesting. I've seen some very interesting use cases for it. For example, if you're writing a game and you want to create an object, an actor or something with some parameters, you can type the name of the class, and it saves you from writing a very long switch, which translates from class names to class instances. However, you should be careful about this feature because essentially it allows you a backdoor to any class in the program, including any libraries. And the reason why I don't like this feature so much because any class you use, any class, whether you use it or not, is going to end up in the executable because it may or may not be used by object.factory.
Yeah, that's probably a bug.
Okay. There's one exception as far as I know. Templated classes won't add an object factory. So classes that are template instances won't be available via object factory?
What about template instantiations?
So you mean that we can solve everything by making everything a template?
Awesome.
I think also your object has to have a constructor that takes no arguments too.
Sorry?
I think anonymous nested class that you prominent in the first slides, it's not useful.
That's right. Very good. Exceptions. We have a hierarchy of exceptions in Phobos. We have very different exception trees, which are errors and exceptions. And the difference between them, as most of you hopefully know, is that errors represent logic errors, which should only happen in a buggy program. And exceptions represent problems that happen due to user input or unforeseen circumstances.
That's right.
Thank you. So what's interesting, and one thing that I wanted to mention about exceptions is that there are some utility functions. You probably know about enforce from SED exception. There are also error no enforce, which creates an appropriate exception object from the value of error no. And W-enforce from Windows exceptions. If you are working on Windows, do not get confused between error numbers and Windows numbers, because one comes from the C library and another comes from the Windows API. So check which API does the function belong to. These are very helpful in actually, what you can do is just call the Windows API function, and if it returns a bool or just non-zero value on success, you can put .wenforce and the name of the function at the end, and you don't even have to wrap it. And you can use the value because wenforce, all these functions, they will return the value if it's non-zero, whatever the type it is. I don't have an example, but you should try it out. Change exceptions. Who knew that our exceptions could be chained? Awesome. So this is a feature that's present in other languages. What happens is that if something in finally throws, it will get appended to the exception via its next parameter. So this program will print a stack trace like this. I would really like to see this used some more. So some things you could, so for example, when you have something like this, you process the line of text and oops, you have an error somewhere. And you need some exception context. Is there a question?
Yeah. Actually, chaining is a bit of a problem because depending on the type of the exception thrown and your semantics, you sometimes want to catch either one, you sometimes want to catch the inner one, and you sometimes want to catch the outer one. So while it is arguably better than C++ that simply terminates the process, in such a case, we're not clear that we're doing the right thing.
What do other languages do?
I'm not sure.
Okay. Something to keep in mind. Yes?
C# do it the same way as D, but Java do it the other way around, like it's chaining in the other direction. And it seems to me that like the Java way is probably more intuitive when you look at the source code and you know, try to figure out what's going on. Because when you throw an exception and you get it appended instead of throwing itself, like you see a type of something that you throw, and then you catch, but you have to catch actually like where it comes from. And yeah, so you throw, yeah, like, you know, you throw a exception and then you catch a exception, but you actually, you know, catch nothing.
Thank you.
I'll just add that C++ fairly recently added a way to query whether you're currently in exception unwind, and that allows some, very reserved here. Some control over whether you want to throw the second exception or not. And I know that due to the problem we've had at WECA with the fact that we're using statically allocated exceptions and the nested exception context sort of replaced, the inner exception replaced the outer exception, causing problems, we were actually looking for some way to know whether we're right now in the middle of exception unwind. So that would be useful regardless.
Thank you. So one question that sometimes appears is like you process a long file and you want to add some context to exceptions. No, you could do something like that. You just on scope failure, which is an awesome feature, you can write the line number or just the line that you had an error with. Another thing you could do is just wrap the contents into a try-catch block and throw a new exception and append the old exception there manually. What's interesting, by the way, is that the documentation currently states that you should not use this feature. This parameter is not to be used by users. But I think we decided that the documentation is just currently wrong and it should be available to users. Any opinions on that?
Can you repeat what should not be?
This parameter right here, when we pass the exception we caught to another exception. So we should not use the next parameter ourselves. And I think it should be available because this is one interesting application of chained exception where you want to add context to something that was caught and to say this is what actually went wrong and this is where it went wrong. Yes?
So this has come up in a number of contexts, including in C++. There is a very simple idea that sort of is latent in the programming community, which is I want to set an execution context here such that if the stack is unwind, I want to that information to be added to the exception being thrown. So it's a very simple API we can add to std exception to say, set execution context, and you put a string in there. And the subtlety there is that you need to, it's not a global. Because there could be multiple scopes that set the exception context, and as the stack is unwound, then it's a very easy API to just automatically add everything. So instead of you writing try and catch and everything, you just say set the execution context. I'm on line, current line, and then automatically the exception thrown is going to contain that information.
Great. One way I found around this is to catch the exception. And did you know that the MSG message field is writable? You can just prepend some additional information to it, and you can rethrow the exception. And what's interesting about this, like, you know how in D exceptions carry a stack trace with them? The stack trace is generated at creation. So when you just rethrow it, you contain the original stack trace where the error really happened.
One thing to notice about the message is that it's very hard to fill in a meaningful message containing information that came from the runtime context of the exception without using the GC.
Yes,
so
that's true.
That's sort of very challenging to use.
I understand that
exceptions.
making an exceptions no GC is something on our short list.
Yes.
Thank you. So this is one way you could, let's see, what is this? I must have written this while I was really drunk on German beer. So I don't remember writing this slide. I think this is an example of, let's see. Oh, there's another way you could do it is to put it in like this and use a function literal. This is just a short way to write this as with a helper function. I'm not going to stop on this for long. Traits, they are awesome. We have a lot. They are all awesome. You should check them out. Each one of them is awesome. And what's even more awesome is std traits. We have a lot of things there that is very awesome. Compile time programming in D is, I have no words. This just blows everything out of the water of any compiled languages. And you should, the traits are what allow introspection to this level. So D is not like Lisp. It's not like you have one data type for everything. We need a lot of trace to query all of our treasures, the features, the types, the everything. Next secret, std.format. You are familiar with this, it's the same as in C++, as in C actually. But we have a few more advancements to the standard C formatting that not everyone might be aware of. Let's say you want to print the same thing twice. Although you could just repeat the argument, you have to evaluate it twice. This is a variable, but it might be an expression. The solution uses positional arguments. This is actually a POSIX feature, as I understand, it's just not very well known. D supports it, but wait, there's more. Let's say you want to print an array. You have a Fibonacci sequence, or recurrence in this case, and you can just pass it as a range to right of ln with a %s specifier. It works. What if you want to drop the square brackets? You use the %parent syntax, which actually opens the array and allows you to specify how to format each individual argument. You can specify a custom delimiter before and after the string. And you can, so if you want to list, you can do that. You can do a lot of stuff. And what's even more awesome is that if you write a custom type, you can specify how to format it. You can, if you define a specially defined toString syntax, which takes a format spec argument, you can invent your own formatting for your own objects. This works for format, for right of ln, for everything that uses those, and it uses async, so this can be NoGC if you want it to be.
Sorry, one question.
Yes.
Is it checking compile time if the arguments are matching the format?
No.
Or will it die like in C?
Currently, no, because we use the C integer conversion functions. That's what I understand, and maybe more things from C.
So our library has a format that accepts the format string as a compile time parameter, as a template, and then we can do all of these checking as CTFE, and we make sure that if it's there, it compiles. And if you have like these funny letters that we do, we just make sure that there is a toString of the right signature, so and hopefully it will do something meaningful with the weird chosen characters, so we know that at compile time it's going to work, and then naturally you also have the NoGC version of it that also gets a pre-allocated memory to spill the result.
Awesome.
Okay.
So it takes the format string as a compile time parameter in stage cases, basically. That's awesome. We should also have that sometime.
Okay, normally on C with printf, if you have an argument mismatch with the format specifier, you either get garbage, you can even get crashes. That's why it's important to have this kind of static checking in C. It's much less important in D, because if you don't know or care what the type is, just go %s. And format will look at the type of the argument and then select a default way of printing that type, which 99% of the time is exactly what you want. And if it can't do the type, instead of crashing or printing garbage, it will throw an exception. So it's really not so much necessary to statically check the formats against the types.
I think most mistakes you just... Usually, I think, when I look behind people's backs, usually what happens is that they don't have the right amount of parameters. So either the format string is too long or you have too short. So the nice thing of doing it at compile time is that you know early that's going to throw. So.
Right, but at least it'll throw, it won't crash.
The problem is, and it's also true of the WEC formatting that Liran was talking about, is that many of those messages don't get accepted unless something bad happened. So they're not in the normal flow of the program. And I know that I routinely get errors from that preprocessor that says, well, you forgot an argument. But the one time I actually got the right number of arguments but gave it an impossible formatting, when it actually came to me, I really took me, I think, half an hour to find out what the problem was, because it was so unusual. But some of those messages you only get to once every year, and then the exception is thrown in production code, which isn't really what you want.
I understand.
Another just general note, the reason POSIX included the positional arguments was to facilitate the localization of a program, so that if you're translating to a language where the order of the arguments is different, you can just localize the format string and get a different output range, and that's actually very important and very missing in C++.
Interesting, thank you.
One thing, this is the first time I hear of positional humans in std format. Was this ever present on the documentation side? Did I just overlook it? Because it's super useful for code generation.
Well, we use a Unix-style documentation, which is use the source, Luke.
No, this is all documented. All this is documented. It's just that it's a lot of documentation. And you know what the problem is? People look at the typical users and says, C-style format strings, awesome, I know this. And they don't even look at it because, you know, it's familiar. Why would someone implement more features there?
And actually, even though it is documented on the website, redundantly also documented in that blue book back there. all of them.
Yeah, I was just going to say that for the most part, personally, I don't think that getting the format specifiers checked at compile time is all that critical. I mean, usually unit testing will catch it, whatnot. There are use cases where that is critical. But the one thing that is potentially critical is then you can make it no-throw. Whereas right now, if you want to use format in any code that's no-throw, you have to explicitly cache the exception and assert that that didn't happen. So that gets a bit ugly.
Yeah, he's right.
And there's a small problem with the example. It doesn't work in safe or pure code. Actually, the delegates needs to be a template. So you can pass in a safe or pure or a combination of that delegate. Just a small side note.
Thanks. Thanks for all the input, everyone. I'm just going to say a few words about some utilities that are distributed with D, and they are not very visible, but they are there. So one utility I would like to mention, and have a honorable mention, is dman. And what this does is that it's like man for D functions. You type dman at the name of a symbol, and it does a lookup, and it opens up a browser web page for that symbol. And it's not something heuristic. It actually builds an index from the D documentation, so it should be quite precise.
10-minute warning.
Sorry?
10 minutes.
Oh yeah, we're almost done. No problem. Next is RDMD. Yes. RDMD is the ideal tool which, well, Zunki, you did an amazing job with DAO. Thank you for your effort. I have a feeling that RDMD is going to drop out of the distribution as soon as DAB gets in, because it almost obsoletes it. But still, sometimes you want something simpler, and RDMD is there. What it does is that you pass the name of the file, and it scans all the imports, and it will build the program with just the imports that are being actually used. Next tool is ddmangle. If you get a scary linker error, this makes it a little bit less scary. So it will take the mangled names and will translate them in readable D functions. You can just pipe the linker output through it. And dump obj and obj2asm, which are written by Walter Bright. If you know assembly, use these to look at what's actually happening under the hood, so you know what's taking up all the time.
I was just going to say that the killer feature of RDMD that Dub does not currently do is you can use it for scripts.
For scripts, yes, you can use shebang and RDMD and the name of the file. DMD actually has a -run parameter, which is good for one module scripts. But if you want multiple modules, you could totally use RDMD. And to close, I just want to say a few words about the deprecated feature of D, the complex numbers.
Question?
Yes.
About dump OBJ, what does it provide in that OBJ dump doesn't provide?
What does which provide, which doesn't provide?
Because since 1.5 year we have demangling support for D in binutils thanks to Ian Bucklow. So what dump OBJ provides that OBJ dump the binutils utility?
Oh yeah, that's a question for Walter.
Okay, I wrote dump OBJ, and the number one reason I wrote it was so I could understand the file format. Because if I write a printy printer for the file format and it pretty prints, then I know that I understand what the actual file format is. So I find it incredibly useful. And I haven't used OBJ dump, so I can't really compare. But dump OBJ works, the same executable works on OMF, it works on the MS-COF, it works on ELF OBJs, it works on Mach OBJs. It automatically detects the kind of file and does it appropriately. So it's very useful, and it has a -P, a pretty print option, so it will dump, for example, all the ELF data structures like the symbolic debugging structures are all pretty printed. Extremely useful for me, the exception handling structures are all pretty printed, which is how I was able to figure out how to implement it.
Thank you. No need to buy an IDA license, just use this. So to close, a few words about complex numbers. They are deprecated, do not use them. But the only thing that they are interesting for is generating very short programs is allowing to write very short programs which generate very pretty images. This entire program creates an image of a Mandelbrot set in portable network graphics format, not PNG, the other one. Here it is. Thank you.